It's a new unit. Moving from triangles to polygons. Lots of sides, lots of things. So that's what this unit is all about. We're going to start with angles of polygons, interior and the exterior angles. We're going to learn a few things, and then we're going to do a few examples, and then we're going to be through. So, first things first, I'm the realist. And then secondly, what is a polygon? So let's start with that topic. Let me grab a doomy flotchy. So, what is a polygon? Polygon. Polygon is a multi-sided figure. Poly meaning multi. Multi-sided figure. Okay. So there is one more piece of kind of early vocabulary that we're going to shove in here at the beginning. Turn that notification sound off. Quit that. Okay, done. And that is that's two actually. Closed versus open. Losed. Closed versus open. Okay, so an open polygon would be something like that. It's open. It's not closed all the way. So therefore, this is an open polygon. So a closed polygon would be something like, whoops, not caps lock. Something like that. Something that is closed. It has all the vertices connected, right? Then, last bit of kind of preemptive vocabulary is convex versus concave. All right. So that's easy peasy. So when I first learned these words, you may have already heard this kind of way of remembering this before. This is pretty common. This is probably not a new concept for a lot of you, but when you think of concave, you think of a shape with a cave in it. So something like this. Let's put the cave right there, right there. See, we've got a little cave happening, right? So it ooches in somewhere. So that's concave versus convex is anything that doesn't have a cave in it, right? So let's real quickly go over some different sizes of polygons and how they relate back to triangles. Everything relates back to triangles. That just is going to happen over and over again. Triangles are important. So are circles, actually. All right, so we can name different size polygons by their number of sides. This you probably know. Now most of these you probably already know. I'm going to mark ones that for whatever reason you may not know. You may have never heard of a heptagon. A heptagon is a 7-sided figure. I'll talk about this column here in just a second. I know, it's there. And you may have never heard of a nonagon before. 9-sided figure. You may have not heard of a hendecagon. You may have not even heard of a dodecagon. But that's how you name polygons by their size. Now, what are we talking about with number of triangles? So let me kind of pop out a quadrilateral. So let's draw a picture of a quadrilateral. So a 4-sided figure. Now, if I go from any vertex and then I connect to the other vertices. Now, it wouldn't work to connect from this vertex to that vertex. See, that's not making anything new in size. We're not talking about that. So if I split it as many times as I can coming from one vertex, then I can make a certain number of triangles. See, I can make 2 triangles. If I have, let's say, an octagon, so keep it green. Green. No, that's ugly. It's fine. It's going to be ugly. It'll be fine. Don't cry. You'll be fine. All right, so let's do an octagon. 1, 2, 3, 4, 5, 6, 7, and 8. So if I pick a vertex here and I start splitting this up, so I won't go here, right, because that wouldn't be inside, but I will go here, and I start to split this up into triangles, this will work from any vertex. I just happen to pick this one. Then we can split it. Again, we wouldn't go this one because, see, that's not a new triangle, right? That's the deal. I can make, for an 8-sided figure, I can make 1, 2, 3, 4, 5, 6 triangles out of it. Now, this is important. Now, you notice it's always 2 less, right? For a decagon, 10-sided figure, I can make 8 triangles. For a pentagon, 5-sided, I can make 3 triangles. All of that. Now, and that's always going to be true. Is going to come into play on our next thing. I also want to note, anything bigger than a dodecagon is an n-gon, n being the number of sides. So if I have a 52-gon, that's a polygon with 52 sides, right? We can keep on doing that all the way till infinity. Once you have infinity sides, an infinitygon actually is something in particular, because an infinitygon also has a special name. An infinitygon is called a circle. A polygon with infinite sides is a circle, right? Well, that's just more of a trivia bit than useful to this chapter, but throwing it out there. Now, we said we were talking about angles. Let's talk about angles. First theorem out of 2 we're going to talk about in this lesson. Polygon interior angle sum theorem. The sum of the interior angle measures of an n-sided convex polygon is n minus 2 times 180. So the number of sides minus 2 times 180. So I'm just going to kind of pop in a couple of examples here. So the one we already know is a triangle. How many sides does this have? It has 3 sides. And we subtract 2 from that and multiply that times 180. Well, 3 minus 2 is 1 times 180 is 180 degrees. So all of these interior angles add up to 180 degrees, which you knew already for a triangle. What if we had a pentagon? So something like this. 1, 2, 3, 4, 5. Now, this has 5 sides. Minus 2 times 180. So 3 times 180 is, I've got that right over here. You can pump it in the calculator, or you can just take my word for the fact that all of these angles in this pentagon, or any convex pentagon, add up to 540 degrees. And that's true no matter how. If I have a 52 gon, then I would do 50 times 180, and I would have the sum of all of those interior angles. It is approaching, well, yeah, I won't even say that. That's I won't confuse you. We'll leave calculus ideas for pre-calculus. All right, let's do an example using that idea. So let's find the measure of each interior angle of this pentagon HJKLM, right? This guy right here. So first of all, this is a pentagon. Now, we already did the math for this one just now. So you would use that n minus 2 times 180 to find the sum of all of these. I'm going to put it with the notes for this particular example just so that it's there. So it's 5-sided figure, minus 2 times 180, 80, and we already know that's 540. So what kind of equation could we set up for this? Well, that's easy peasy. It'd be this one plus this one plus this one plus this one plus that one equals 540. So let's do that. 142 plus... Now you notice these two repeat and these two repeat, so I'm going to kind of write this in a shortcut way. Does that sound reasonable? Let's do it. 2 times 2x, because there's 2x's. Plus 2 times those. Sometimes you can do that. You could also just do this plus 2x plus 3x plus 14 plus 3x plus 14 plus 2x equals 540. You could write it all out if you wanted to, and that would be totally fine as well. This is going to require us to do a little distributive property. You can do it. I have faith in you. And that's going to equal 540. Now we're going to solve for x. Let's do it. So we're going to distribute. Well, this one we're just going to multiply, and this one we're going to distribute. So I'm going to bring down 142 plus 4x. 2 times 3 is 6, so plus 6x plus 28 equals 540. So then we've got some like terms. We've got this one right there. with this one right there. They don't have any x. These both have x's. Right? So 4x plus 6x is 10x. 10x and 142 plus 28. That would be what? 150 plus 20, 170 plus 170 equals 540. And then we'll subtract off the 170. And then we've got 10x equals 540 minus 170. That's going to be like 370 something. Something like that. Give me a second. All right. So 540 minus 170 equals 370. Yay, look, I was right. Isn't that what I said? I don't know. Roll back the tape. Divide by 10. That one's easy peasy. We can do that one without any trouble. So x ends up equaling 37. So to find these measures, we're just going to plug it in there. So for this one, it'd be 2 times this one. It would be 2 times 37, which is divided by 10, just to get it in there, and then times 2. 74. So this one equals 74 degrees, which means this one equals 74 degrees. Let's plug it in here. So 3 times 37 plus 14. 3 times 37. 3 times 37 equals 111. 11th birthday plus 14. So that would be 125 degrees, which means this one is also 125 degrees. We done did it. All right. One more theorem and another quick example, and then we are through with this lesson. So, what about exterior angles? So, this one is written a little bit. It's a little confusing to read. Let's read it and go for it. So, Polygon exterior angle sum theorem. Sum of the exterior angles measures of a convex polygon. One angle at each side. Each vertex is 360. So, what does this one each at each vertex mean? Well, at this particular vertex, there are actually 2 external angles. There's this one and that one. But for this theorem to work, we're only taking into account 1 at each, which is why it kind of looks like this. You could also do it this other way. So in another color, I can pop in here. So you could go this way and do like this one and that one and that one and this one and that one and that one. And you would get the same thing, right? So you can go around either way once, all the way. And their sum always, now you notice this is not, it doesn't matter whether it's a pentagon, a heptagon, a 5,280gon, anything, no matter what, the sum of the exterior angles of the polygon are always 360. So this one plus this one plus this one plus that one plus that one plus that one equals 360, and that's always true. Always. If we're talking about exterior angles, their sum is always 360 degrees. Let's do an example with that. Whoop, ugliness. There it is. So we're going to find the value of x in this diagram. So we've got a bunch of exterior angles drawn out. So we know no matter what size, what shape is this? Say, what shape is this? 1, 2, 3, 4, 5. So in this pentagon, all of the exterior angles add up 360. If it was a triangle, it'd be the same sum. If it was a hexagon, it would be the same sum. Whatever. So to do this one, all we have to do is add these up. So 2x minus 5 plus 5x plus 2x plus 6x minus 5 plus 3x plus 10. Did I get that 2x, Mike? Yes, I did. So equals 360. Kind of ran out of space there. I apologize. It's a little bit ugly. So we got some like terms. Let's combine them. Let's do 2x and 5x and 2x and 6x and 3x. And then we'll also do -5 and -5 and 10. Ooh, that's nice. If you don't see why that's nice, then hold on to your hats. It's going to happen. So 2x plus 5x is 7x, plus 2x is 9x, plus 6x is 15x, plus 3x is 18x. So we've got 360 equals 18x. -5 plus -5 is -10. Plus -10 is 0. Yay, it cancels. That's quite nice, isn't it? So these all cancel. All those non-x's all cancel out. So we're going to take and divide this by 18 on both sides. And x is going to equal 360 divided by 18 equals 18 1/3. There it is. That's it, kids. We'll see you in the next one. If you're one of my students, do your homework. I'll see you in class. If you're not one of my students, hopefully this was helpful to you. We'll see you in the next one. Bye-bye.